Hey yo, what is up guys, Akash here, back with another video. Recently I was looking for a Bluetooth module for my project, and we are all familiar with this SR05 or SR06 module, which we find easily on Chinese websites for like $3 or $3.50. But yeah, this time I got something new while my browsing. So we are all familiar with the company Reax, of whose LoRa modules I use generally. So they provide Bluetooth modules as well, and I was tempted to try it. So I got this RYB080 Bluetooth module. So these modules are this tiny modules. So these cute tiny modules. So these are so small. If you have an ESP012 to compare it to, so you can probably fit 2 or 3, and maybe with the ESP07 you can fit 2 as well. So this is very small Bluetooth module, very suitable for wearables. You cannot use this big of a module in products like those. So I was looking for a small solution and I found this. So Reax also provides this module, which is a breakout module for the same module. And yeah, I rigged up a small demo. I wrote a code with an ESP8266 and connected this module to it. They provide an app with it, so I just need to press connect, and then it'll search the devices. There's the Reax BLE, and yes, it gets connected. I just need to type in the word LED, and I've programmed it so that the LED toggles when I send this message. So as soon as I send this, the LED switches off. If I send the word LED again, now this LED switch should switch on. So this thing is happening over Bluetooth. We will see how we can make this. We will understand how we can use the Reax module, what are its benefits over the older Bluetooth module and all that. So if you're interested in such a topic, stay tuned to the video. I recently came across PCBgogo.com. They are one of the most experienced PCB manufacturers from China. They offer 10 PCBs for $5 only, with several shipping partners. They even offer 24 or 48-hour express service. Apart from getting your PCBs manufactured, you can even get PCB assembly, layout and stencil manufacturing as well. Do check them out. All the relevant links will be in the description box below. So to understand about this module in a better way, I got its datasheet. So moving these modules aside, so this is the datasheet for this cute module, and there we have it. It says 2.4 GHz, Bluetooth 4.2 and 5.0, and it's BLE enabled with an integrated antenna. So obviously you get an antenna over here, and what the benefit of this module is that it's serial based, and you can control it over 80 commands as from the other popular products from Reax as well. So moving on to the data sheet, so it works on the 3.3 volt logic levels, and so it's very good for using with an ESP module. If you're using it with an Arduino, then you'll have to use a logic converter or something like that. And this is the pinout of this module. So there it's something like this with the antenna placement like that, and we can see that there are many pins, and the speciality of this module is that there are 4 GPIO pins that can be controllable without any external microcontroller. So this module has an inbuilt microcontroller. Using 80 commands we can control these GPIO pins. So that's pretty cool. So moving on to the next, so we have different pins setups. Then we have application. The module uses the CC2640R2F Bluetooth engine from Texas Instruments. Then there's this soldering. So because this is an SMD part, it's probably very difficult to solder it by hand, but you can if you want to. The pin spacing is very small, so I suggest you get a breakout board as well. But when you're putting it into production or something like that, or you're using a pick and place machine, you should use this one, as this module is like more than $5, a little bit more than $5 on eBay, and this is $1 cheaper. So this breakout board costs you $1. And so I'll put in all the relevant links in the description box below. This is the breakout board, and some FCC statements. Now moving on to the AT commands. Basic AT commands we see is that we can set AT reset. We can set the name of the Bluetooth module. So right now it's set as Reax module, which we see when we use our app on the Android smartphone. So it's set as Reax BLE RYB080l, and you can change this name using this AT commands. For that you can't do it over the Bluetooth, so you'll have to connect this module to your laptop or computer, which we'll do very shortly in this. And then we have different attribute setting, we have power setting that we can do. Then we have other AT commands as well. We can set inquire about the MAC address, so every Bluetooth Wi-Fi device has a MAC address. Then you can connect it to two devices simultaneously, so there are two Bluetooth ports, which is very interesting. One you can connect as a host and the other as client, which can find its application in many ways. Then we have other, so there's this AT plus GPIO control thing that we can use, and you can just use this command. So this is a very handy data sheet. There's this user guide available as well on their website, and I'll link this in the description box below as well. So I'll link a GitHub repository probably, and you'll find everything, all the relevant data, even the Android application on the same GitHub page. So that's it for the data sheet. Now what we'll do is, before making the project with the ESP8266, firstly we'll connect this module directly to a computer using an FTDI chip. So using the RX and the TX pins of the module. So we have 5 pins over here. The first one is ground, then we have reset, then TX, then RX, and then we have VDD. So we'll connect the RX of this Bluetooth module to the TX of the FTDI module. The RX of the FTDI module goes to the TX of the React module, and so does the power and the ground. And this FTDI board already works on the 3.3 volt rails, so there's no issue of voltage conversion. So let's set that up and see what we can do. I've connected this FTDI module to the React module, and I'll pop in a serial monitor over here, and you can see as soon as I connect the ground pin to the FTDI module, we see some statements over here, that is ready and enter, and that is supposed to happen as soon as this gets powered on. So we hit the connect button on the Android app, and we can see that the module is showing over here, so we can connect it. We hit the connect button and it gets connected, and on the serial monitor we see that there's this plus C1, that means a client has connected to this module. Apart from that, then we see some MTU details. I'm not sure what that is about. Probably that is the MAC address of this, the first 2 digits of the MAC address of this tablet we have. Now we can simply start by writing a message over here. As soon as we send hey from here, we see that it's received on the serial monitor of the Bluetooth module. Now what the Bluetooth module is programmed right now is that it is on a 5-second sleeper timer. So if it's inactive for 5 seconds, it gets into sleep mode. So if I directly send some message from here, say suppose hi, so I've sent that from there, it will not show up here. But we should send simultaneous messages with a delay of less than 5 seconds. So if I say Akarsh here, so I've sent that. Now I say hi again. So now we see that there's this plus OK message that we receive, and we see the hi message over here. So that is how it works. In short, to make it to transmit messages, we need to put it out of sleep mode. But this sleep mode is the default mode. As we can see in the data sheet, there is other modes available. So right now it's set to the default mode, that is the standard power saving mode after pin 4 was triggered, and that is the 5-second mode we just saw. Then we have this fully functional mode as well, so we can use this command to turn the module into that mode. We can also use other AT commands, so we'll test that right away. And let's keep my tablet here as well, so that we can see if there's anything on the tablet. So let's say AT, and because it's in sleep, we need to type in AT again. So it says okay. So the first letter should be a capital A to wake the module up. So let's say AT plus reset. Let's see what happens then. So let's say AT again, and then AT plus reset. So yeah, it got reset again. So let's send a module hi CETech. Let's send that module, and that is not received because the module has got disconnected because of the reset. So we'll disconnect it from here, then we'll connect it back again, and let's connect it, so it gets connected right there. Hi from CETech. I'll send this message, and there we go, we receive it over there. We send AT command, it says okay, then we say hi, and it gets received instantaneously over here. There's no transmission lag that you will notice, so we can try out other AT commands as well, but instead of this we'll move on to a project, which is this project that we made, and I'll explain you how I made this, what are its basic connections, and then we can see how it works, and we can take the scope of this Bluetooth module further. So this is the simple circuit that we are using. The VCC pin of the Bluetooth module from React gets connected to the VCC module of the ESP8266 from DF Robot. So this is the Firebeetle board from DF Robot of the ESP8266 that we're using for this project. And then there's the ground to ground. The RX pin goes to the IO4 pin of the ESP8266 board, and the TX pin goes to IO5 pin of the ESP8266. Apart from that, we have added this LED which gets toggled using the Bluetooth on GPIO pin 15 of the ESP8266, and the other side gets connected to ground. It's a 3.3 volt logic level pin, so there are no converters needed in between these two modules, and this LED is also fine on 3.3 volts. There's not much current delivered to this LED that it can get damaged also. I wrote 20 line code for this circuit, so coding is also not difficult when using the module from React or the ESP8266. I've done that connections over here, so we see the white and green wires for the serial communication and the black and red wires for the power, and then we have the LED hooked up directly. So now we just need to connect the power to the ESP8266 module, and there we go, and the blink light shows that it's on. Then we need to launch the Bluetooth app on the device. Then we need to hit the connect button. We'll see that the Bluetooth module is discoverable and it gets connected. Now when we send a message, we send LED, it should receive that, and yes, it does receive it, and it toggles the LED. Now again we can send another LED message to it and it'll switch it off, and that is how the project works. So it's a pretty simple project that we have made. It's just for understanding that how can we use this module. So it's not directly connected to the serial port of the ESP8266. I've used a software serial library, so there are two serial ports actually. If I connect this ESP8266 to my laptop, we can see the different messages there as well. So this is all about this video and how we can use the RYB080. This is a pretty basic video of using this module. I'm thinking about developing my own breakout board so that without any ESP module we can just use this Bluetooth module stand alone. Let me know if you guys are interested in that. I'll design the PCB and then we can see what we can do with that. We can make an interesting project or something. Thanks for watching. Subscribe to our channel if you haven't till now. Also hit the bell icon to stay notified. This is Akash signing off.